a sequence of events? Yeah, right. Put the cartridge in the chamber, turn the safety off, you pull the trigger, the bullet comes out of the barrel, hits a target, right?
Sounds like you're talking about
Hopefully a valid target. So that's a sequence of events, correct? Well, in mathematics, we have something that's very similar. Of course, it's numeric, right? So a numeric sequence could be something like this.
So it's constantly increasing.
This one is increasing is what we would call it, right?
Oh, so this is like an arithmetic sequence, right?
Yeah.
I saw it on like a test or something.
An arithmetic sequence adds or subtracts the next term.
This was on.
Right? We will talk about geometric sequences tomorrow, which multiplies or divides the next term.
They said which wasn't. Okay.
So that's a sequence. Can you think of a formula that would define that sequence? Oops, what's x?
Or no, n divided by 2.
Okay, so we would say f of n equals n over 2. Does it work?
No.
What if n is, and these are always defined as integers. So if n is 0, it should be, the value should be 1. Does this work? No, okay. Sorry. Okay. Is the top number always the same?
Yes.
Okay, so we know that the top number will be 1. How can I define the bottom? Okay. Is the third term 3 on the bottom? No, so n plus 1 doesn't work. N squared? Okay, so 0 squared is 0. Does that work for the first term on the bottom? 1 squared is 1. Nope, not working.
No, but that.
N times 2.
Wait.
What's 2 times 0? Doesn't work. 2 times 1, 2 times 2.
N
Is
plus
that
1
2 times 3? No, okay. If I said 2, 4, 8, 16, 32, those are what?
So wait, what about
The
n?
powers of 2.
No,
Right. 2 to the 0 is 1. 1 over 1. 2 to the 1 is 2, 1/2. 2 squared is 4. 2 cubed is 8. Right, so we've just defined a sequence with the formula.
So there was calculus on the knowledge book.
It's not calculus. Okay. We can define our n values differently. Okay, we could say n equals 2, 3, 4. Okay, you can define it anywhere it starts. Okay, but they are always integers. Okay, the n values are always integers. So we're taking a step back from calculus. We've always worked with the real numbers where we can go inside and do any decimal, right? Okay. Right now we're working with integers. So,
Yay.
yay in many respects, yes. Okay. Now where are we headed with this? Okay, a sequence as such, this whole chapter is studying series. Very similar to Taylor polynomials. The Taylor polynomials were a great primer for this. Does anybody have this Taylor polynomial for e to the x memorized yet? Cheater. Factorial. Okay. So a sequence e to the n would be 1, 2, etc., right? But a series is these terms all added up. Right? So the difference between a sequence is term by term, a series is the terms all added up. Okay. And we can approximate functions with series polynomials or Taylor polynomials. Right, so we'll get into this more in the next few days, but today we're going to focus on sequences. Okay. So let's look at a recursive sequence. You computer programmers.
Recursion, looping it.
Okay, let's define a to the. Okay, so sequences, let me back up here. This would be a sub 0, this would be a sub 1. All right, are you okay with that notation? This is a sequence, term 0, term 1, term 2, and that's your n value, right? Okay, so if I define a sub 1 as 1, right, first term is 1. And in a recursive sequence, you have to have a first term defined. Okay. Recursive means the next term or any nth term is defined by the term prior.
Wait, why would it be 1/2 of?
It's just what we define it as. This is a recursive sequence because the next term is defined by the term before it, right? So if I want a sub 2, it is defined by 1/2 a sub 1 plus 2 over a sub 1, right? So what is term 2?
A1.
Which is 1 plus 2 over 1. Okay, that's 3 over 2.
3 over 2 divided by 2.
No, that's 3 over 2.
No. Oh, yeah.
Right, 3. And then divide by 2. Okay, now what's a3 then? 1/2. 3 over 2 plus 2 over 3 over 2. Okay, so it's a recursive sequence defined term by term, right? 4/3. Oh, we're going to have to write this down so I don't screw it up. This is 4/3, right? Nine sixths and 8/6, 17 over 12. Right, so you keep it, right? So that's a recursive sequence. Okay. The real question that we need to answer is something called convergence and divergence. Okay. So our question here would be, does a sub n converge? Okay. And what does that mean? Now, does this word have any meaning? You bet it does. Okay. Does it converge? Okay. Graphically, if I have a sequence A sub n. What would this sequence be converging to? Zero? So you tell me this is going to hit the x-axis at some point, or not converge to it? Oh, you said what?
We said no.
Oh, I heard zero. Yeah, so we would say that A sub n converges to 1. Does it ever cross 1? Maybe. But the point is that as n approaches infinity, right, A sub n approaches 1. Right. So we would say that sequence converges to 1. How can I write that in calculus terms? This is pre-calculus notation, right? We learned that in pre-calc together. How can I write that in calculus notation? Of what? A subscript, right? Sub. Now we're in calculus notation. Right? So this is how we determine, does a sequence converge? It has to converge to the limit as n approaches infinity has to get a number. That's it. Yeah. So if there's a number here, A sub n converges. What do you think it's going to be if we diverge? So if we diverge, what do you mean by mathematically? That's better. Yeah, it goes to infinity. Right. And so we would say that sequence diverges. You with me? Sort of. Oh, well. Is this a mathematical issue?
Yes.
I would think not. Converge or diverge? Limit as n approaches infinity, 1 over 2 to the n. Okay. Have we defined limits for integers? Have we defined limits as an integer operation or as a real number operation? Right. So we can't actually do this problem.
Well,
But we can.
Those numbers are approaching
Here's what's really neat about this. Okay, what would you intuitively say the answer to this question is? 0, right? So we would say this converges, right? So that's like intuitive. It's not formal mathematics. Okay. Formally, we have to change that into a function. And here's that really neat. Here's a really neat theorem. if the limit as x approaches infinity of f of x exists so we've got a function there, right? A sub n, which equals f of n, right? Notice the notation's the same. We've just put it in integer format now. Converges to the same limit. Okay. So, formally in mathematics, this is not something we would do, but we would say, well, that will be the same as since this is true, so we would say since, right? A sub n equals 1 over 2 to the n converges. Okay. Now we're formally and properly accurate. A little nuance.
Just looks like a lot of extra work.
It does, but if I'm to prepare you for college, which 4 out of the 5 you're probably going to do, this is something that you have to know the difference of. It's a little thing. Like when you think of solving these sequences for convergence, you're not going to worry about it, honestly. You're going to go with your intuitive, right, solution. But formally, this is what has to happen. Let's say this. You can do this because that works. Okay? Because the theorem, it allows us to use this as a solution method. Right? So what about let's try it. Find the limit of sequence sequeno. And then I'm going to give you do you know what sequence is? What's a sequence? A sub n. Okay. What are n values? Right? Okay, so now to calculate the limit of this formally, I do have to turn it into a function, right? Yeah.
Like we use a sub n here when
Is this a sequence? Proper mathematical notation for a sequence is to call it a sub n. Okay. Some people call it S sub n. S is a sequence with term n, which I think makes sense. But so this, if I put f of n here, I would be defining it as a function with variable n on the real numbers. If I call it a sub n, I know it's a sequence on the integers. It's just a little thing, but mathematicians, when they see this, know exactly what we're talking about.
So it's just true that it's
Just a sequence, not a function. But we have to turn it into a function to calculate the limit, right? Because this is defined on real numbers. It's kind of silly, kind of. I know, you're like shaking your heads, what the heck? Okay, yeah, that's on YouTube. Limit here? 1, yeah. So does a sub n converge? Right, so a sub n converges to 1. Right, okay. So you'll just be you want one more example? Yeah, okay. So basically what you're doing is you've taken a sequence and you've just put it into your limits knowledge. That's all we're doing. It's really, the only thing new is, what is a sequence, right? Right, Hunter? Very confident. Calculate the limit as n approaches infinity. N equals ln over n squared. So, we're asking calculate the limit of the sequence, right?
So then you have to change it to x and then
To properly solve the problem, you have to change it, right? So
my question is, why would they write it that way if they knew that we had to do the opposite?
because it's not a function. It is
No,
a
but
sequence.
They'd be saving us work.
Sometimes that's always a good thing. Here's the problem. You see that question over there? Do words have any meaning? So we talked about that earlier, right? There's a difference between these two things because they have meaning. We cannot we cannot reconcile. That was not my intent, but it's working. Thank you. We cannot reconcile this limit without the real numbers. That's why we have to do this. And believe me, if this was able to be done without switching it, somebody would have figured it out by now. The fact is, this is how we have to do it. Okay? Because that's how things are defined. What?
How did they choose the letter N? How did that come about?
Number?
I think integer, number.
That's my guess. I have no idea. Honestly, I would have to think about that because it's been 15 years since I was in math history.
That means n has meaning.
N is an integer, right? A whole number, whereas x is a real number. Okay, so solve that limit. If I plug infinity in, what do I get? What's that called? It's an indeterminate form. Okay, how can I solve it? Can I algebra it? No, it doesn't get us anywhere. What? Let's try it. L'Hopital's rule. One plus 1 over x, or 2x, right?
Now we can start plugging numbers.
What does this go to here? As that approaches infinity, this is 0, right? What does this go to? So the denominator goes to infinity, the numerator goes to 1. What's the answer? It does. So a sub n diverges. Right? Why'd you say 1? 0. Why'd you say 0?
Because the top just goes to 1.
Oh wait.
It's 0.
Goodness, what am I thinking?
I don't know.
I'm glad that we caught that. Okay. bottom 0, infinity, whole fraction, 0, so A sub n converges. That's a little different result.
Oh, yeah.
Sorry. I thought I was going to get away with not making a mistake today. It's always... So, you're calculating limits. That's all we're doing right now. You notice sequences can be calculated. Okay. Big steps.
I heard my head right there for a second. It's like, what?
Tomorrow we'll work a little bit more with this, with geometric sequences, and some more examples. So here's your homework from 10.1. It was prelims 1 through 5. If you get to some, if you're working on it tonight, you get to some that you can't do, just stop. Because there will be some that probably we're into the AP 7s now. This is not due until, what's today? Friday. Talk, y'all. Oh man, you sneeze so much that you're sore, like this area here. Oh gosh. Yeah. Hunter.
I'm trying to